Okay, so once again, good afternoon, everyone. Uh, I'm audible.
Yes, ma'am.
Okay, my screen is visible properly.
Yes, ma'am.
Okay, so in last lecture, we are starting with the just a basic introduction about multi-threading and introduction to GUI programming. Okay, that will be the fifth unit. So in this fifth unit, we are having the only 4 points. First is a thread-based parallelism. Second is a process-based parallelism. Then context variables, synchronous I/O, and a main concept that will be the GUI programming in Python. Okay, so now first we will see what is thread. So thread means what? It is a simple words. A thread is a sequence of such a instructions within a program that can be executed independently of the other code. Means what? We call it as a it will be the reusability of code. Means what? You have to see here the figure. In this figure we are having three different threads. Okay, so each and every thread is having their own local variables, their own global variables, and the code piece of code which we are writing in that thread, it will be having a different logic. Means what? Each and every thread is having their own logic. Okay, so means what? The thread means what? We are writing any of the code is in individual platform. Like suppose we are considering the example of arithmetic. Okay, so in arithmetic we know that we are having addition, subtraction, multiplication, and division, this all the operations. Okay, so here what will be happen? Thread means what? We are writing the program in the format of like a, for addition we are writing separate thread, for subtraction we are writing separate thread, for division we are writing separate thread, like that. Okay, so if we are writing this all the different arithmetic operation in the single unit, so what we call it as a, we call it as a process. Means what? If we are writing all the arithmetic operation in the a single program, so we call it as a, that will be the process based parallelism. And thread based means what? We are writing each and every program in the individual point of view. Okay, so this will be the basic logic about the thread based parallelism and process based parallelism. Okay, so so we call it as a threading. Means what? We for thread we also call it as a multi-threading. Means what? We are executing number of processes or number of programming units in the a single, so we call it as a multi-threading technique. Okay, so suppose we are sharing some of the data space with main thread inside the process. Means what? You have to see here the this figure. Okay, so the part which is indicated in the blue color, that will be, we call it as a, that will be the process. In that process we are accessing all the data by using the global variable declaration through a thread. Okay, so by using this global variable declaration we are increasing the performance of our program. Means what? We are doing a thread also, but by using a process. Okay, so why we need to do this threading? So we are having some of the benefits for that. So first, that it is ensure that effective utilization of computer system resources. Means what? Suppose we are doing the arithmetic program in the a single unit. Okay, that time we need a different four spaces for storing a storage of that data. Means for addition we need one, for subtraction we need like that all. So if we are doing the process based parallelism, that time we are utilizing a small piece of, means we are able to we are able unable to, means like uh, here we are using a limited resources for the multiple programs. Means what? If we are doing each and every program single, means like in one way, that time. Hello, hello, any doubt? Anyone having doubt? Okay, so means what? If we are using we are writing by using thread, that time we need a more space, but we are doing the process based parallelism, that time we need a less space. So uh, 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 we are using, every time we are using the process based actually parallelism, we are using process based, not we are using, not using thread based parallelism. Okay, so for that we are having many more concepts. So the multi-thread application are more responsive, means what, the result as compared to the result of the thread based parallelism, process based parallelism is having good results. So it save the time by executing a multiple threads at the same time, means what we are doing in process based parallelism, we are executing number of threads in the a single unit, so we call it as a, it will be save of our time, and also we need a little space. Okay, the system does not require too much memory to store the multi process based parallelism, means what, if suppose we are doing thread based, so it will be take the more memory space, but if we are doing the process based, it will be it is not needed to more space. Okay, so how to create any of the thread. Okay, this part will be the theoretical part. How to create a new thread in Python. Okay, so for creating new thread, suppose any thread is in Python are entity within a process that can be scheduled for the execution, means what, suppose now we want to create one of the threads. So for creating the simple thread, we first need to know that how many processes, how many process, means suppose how many threads are there. Suppose we consider as a only one thread. So at that time what we are doing, we are first of all we need to create the class of that thread, the class which we want. Okay, so in that we are having one more we are having after that we are having some of the concept if we want to create a new thread. So in that creating a new thread, we are having some of the processes pointers which we know, that we call it as a thread control blocks. Okay, we call it as a thread control block. So so thread control block is having a thread ID identifier, means what, unique ID, which we assign for the new thread, means what, if we are creating any of the new thread, we are giving some name to that thread, so we call it as, that will be the unique identity of that thread. Okay, then next will be the stack pointer. So why we need here the stack pointer, because points to thread stack in process stack contain the local variable under the thread. Means what, you have to see in this figure, we are using local variable also and the global variable also. So the stack pointer will be give us the location, or it will be indicate that where you have to store your data, it in the uh, global scope or it in the a local scope. Okay, so that work will be done by the stack pointer. Then program counter means what, everyone learn that in microprocessors, the work of program counter means that a register which stores the address of the instruction currently being executed by the thread. Means what, suppose in thread program we are doing the addition, so for addition we know that a is equal to b plus c is my main logic. If I am not writing this logic, so my program will be not give me the proper output. So the program counter will be directly address that point, means what, the logic which we are using to execute that program, that will be a is equal to b plus c. So the program counter will be store the address of that instruction that we are executing to get some of the output result. Okay, then thread state. So thread state can be can having the thread state can having a many more steps. So you have to see here the figure. My screen is visible.
Yes, ma'am.
Okay, so you have to, first of all you have to see here the uh, uh, thread life cycle. Okay, you have to see here the a thread life cycle. So in uh, thread life cycle, you have to say, see here total main four steps are there of the thread life cycle. First one is a new, then second is a running, then runnable and terminate. Okay, so these are the steps. Okay, so new state means what? We are creating any of the new thread. So we call it as a, that will be the initial stage or new state. Okay, so that after that, if I will enter to the next, here running step means what? Running means what? We are getting the time from CPU to run my program. Means what? Suppose I will write one program in my ideally, and now I want to run that program. So that time what I am doing, I am just going to that compiler, and I want to try to execute that program. So for execution of that program, I am having some of the step. Like first, we need to compile, or we need to debug that program. Okay, so like that. So running state means that, and runnable state means what? Waiting for CPU. Suppose at the same time 2 to 4 processes are there. At the same time 2 to 4 processes are waiting to execute their program. So that time what happened? That time our program will be for waiting state. Means what? It will be wait for the CPU will be give the chance to the execute program. If there is no any space, directly new state will be going to the running state, and after running state it will be move forward. That will be a terminate, means it will be complete with the execution. Runnable state is having some more points that will be like acquiring a acquired means what? Blocked state means what? Suppose I having 3 threads at the same time I want to run. So in that I want to block the second thread for the execution. So what? That time what happened? My program will be start. After that it will be enter in the running state, but within a fraction of second it will be moved towards the runnable state. Means what? It will be their message will be displayed like a lock acquired, or it will be acquiring lock. Means my system will be not allowed to execute that program for that a specific thread which we are mentioning over there. After waiting for notification means what? If suppose many threads are there, so that time what happened? We are waiting for the our turn. So that time there the system will be give some of the notification. You are ready, or your device now it will be allowed to you to execute your program, like that. And sometime what happen? CPU will be give the specific time to execute your program. Like that, we consider the example of our lecture. We are having 2 hours lectures. Okay, but what happens? Suppose sometimes I will start with the some of the concept at the end of that time. And what happened? I need a 2 to 5 minutes more to complete my that point. But what happened that time? Other faculty will be already share the link, or already waiting for their lecture. So that time what happened? I will be displayed here. Some message will be displayed like that. A timeout will be there. So if I receive the message that will be a timeout, that time it is the machine will be uh, directly deactivated. Means what? Your timeout will be there, and it will be the give the time to wait. Means what? You have to now wait for your turn, like that. So this will be the a simple life cycle of thread. It will be having new, running, runnable and terminate state. Okay, any doubt is there in the this CPU life cycle? Yes, anyone having doubt? I'm audible.
Yes, ma'am.
Okay, so everyone understand this a thread life cycle. Okay, now we will move further. Then next will be the thread register the state. Register the state means what? We are having many more registers. We know that we know that we are having many more registers. So this register set will be assigned the different registers as compared to as known to their requirements. Means what? Suppose I want the register to store the only 2 to 3 lines of instructions. So that time the register set will be decide which location or which register they have to allow to them to store or acquire their address spaces or data. Okay, and then after that PCB means what? Parent process pointer. A parent process means what? This PCB block means what? A pointer, the pointer location to process control block means what? That pointer will be a give the some of the restriction means what? We are using the resources which we are available, that will be in the some of the control format means what? The process that will be, we call it as a live means what? Suppose any live process is going on, that time suppose here you have to take the example of our lecture. If suppose I will, what I should do, I will ask anyone to speak, but what I should do, I will as a host I will remove to you in meeting. After that you are unable to join that meeting. Why? Because you are joining once in this meeting, but what I should do, I will left you, I will remove you. So if I will try to, if I'm not giving access to you to join this lecture, so how you have to join? So means what? We call it as a, it will be the, this PCB block will be work with the a live thread. This will be work with the live thread. Okay, so this will be the totally about thread based process and thread and this all the steps we are using in the a thread life cycle. Okay, and the process base, the theoretical part will be there, that I already told you. That will be the difference between thread based and process based parallelism. Okay, so some of the examples of the thread based parallelism is what? One is we consider the example of a Microsoft Word file which we are using. Just a minute. So suppose here I'm what I should do, I will type some of the words over here. So you have to see here. Here the red line means what? It words is not available in their dictionary or some mistakes are there. So we know that such a lines, if suppose we are working with the word file, that time sometime what happen, if suppose I will uh, uh, okay, I will make the spelling mistake here. You have to see carefully. If I will do the a spelling mistake over there, so it will be automatically after giving it will be give me the red line, and it will be give me the some of the suggestions means what? Your spelling is like this or like this, so my spelling is like this. So it means what? It will be automatically check the spelling, and it will be make the changes over there. So we call it as a, this will be the live example of thread. And other example we consider as a other example we consider that will be the example of the browser. At the same time here you have to say, here my browser is there, here I am using different tabs like a mail, here I am using Google Drive, here I will open the Go collab or many more things. Here my WhatsApp is open, and suppose here I will add and I want to search something. So we consider as a, this example will be the web browser is a one of the best example for the thread. Why? Because at the same time we are using number of threads, the different tab, we call it as a multiple thread, but that all the tabs is we are this these all tabs are working in the single unit, so we call it as a, that single unit is called as a process. Okay, then the some of the applications related to a thread, that will be the first operating system. So in operating system we know that we are having all built-in packages, we call it as a, and all the that built-in packages we are accessing through the different process. OS, operating system, so we know that we are having many more operating systems out there. So uh, So each and every operating system is having their own individual uh, opinions, we call it as a. So this will be the application, we call it as application for thread, that will be the OS, operating system. Then web browser is also one of the application which we are using to do the threading or process based threading. Then web servers, we are using a different servers to execute, like we consider the example of online compiler which we are using to execute the Python code. So we know that there is a no single compiler are there. There are many compilers. If we are search on the just Google Python online compiler, it will be give us the many more results. So we call it as a, that will be the one of the best example for the thread application. So the difference between thread and process is what? So a thread is a lightweight. Can anyone tell what is the meaning of lightweight? Yes, what is the meaning of lightweight? Yes, anyone? What is the meaning of lightweight? Yes, what is the meaning of lightweight? Yes, lightweight means what? Like we call it as a halka. It will be a not having more weightage. Okay. So and the process is what? Process we call it as a under execution or active process. Means what? We are using this number of thread in the single process. So we call it as a, that will be the a program under execution. Then the thread means what? A thread required time to execute their program, but process is not required more time. Okay. So this will be the a simple overall a description related to process based and thread based parallels. Okay. So now we will see here, I will explain the program how to create any of the new thread, and after that we will see the program. Okay. So here I am writing the simple program for thread based thread means what? For creating a new thread, first we need a thread, a thread model means what? We are we are here initializing that thread, import threading, okay, package. Then after that, here I am taking one of the class, that will be a thread class. In that it is a compulsory to write a threading dot thread. Why? Because here we are suppose in single program we are writing more than one thread. So here we need a threading dot thread. Okay. After that, here it is a compulsory, you know that that will be the colon symbol. After that, here what I am taking, here I am taking one of the function. In that function I am taking a self. Can anyone tell what is a self keyword? Self keyword means what? It is used to represent an instance of object of the given class. Means what? Which class here we are using? We are here declaring the a thread class. So we call it as a this self keyword will be the instance object of this class. Okay, and after that here we are taking thread name and thread ID. Means what? Here I am taking the two variable declaration for my creating a new thread, that will be the name of thread and the ID of that thread. Okay, so here after that what here I am here double underscore is needed if we are giving the a single underscore, it will be a not accepted, because this will be the syntax for a thread. Okay, after that after that defining of the any of the function, threading dot thread of initial to self. Why we are calling this initial function? Because we are here in this initial function we are mentioning the variable which we are using for our create our in our thread. Okay, so that we are calling after that a self dot thread is equal to thread name and self dot thread id is equal to id. After that we are taking one more function definition, that will be a run. Means what? We are executing that a self. Means what? Self means what? It will be create the instance of this class, that will be the thread class. After that print str of self dot thread name the and self id. Means what? Here I am taking the in single line the representation like this. Okay, so after that here just creating I am object of this thread, that will be thread 1 is equal to thread of for name, and after that thread 2 same I will create. Here I will put some of the messages like we call it as a name, and here id I will put. And what I should do here, you have to say here I will start a thread 1 dot start. Means what? Start means what? Here I am only executing thread 1, here I am not executing thread 2. So now I will execute this program. So you have to see here it will be a return me only high and 100. Why? Because here I am just starting the execution of my thread 1, and now I will start the execution of thread 2 also. So that time it will be a display me the output of the both the thread. Okay, okay, so this will be the simply example of the thread which we are using, means how to create a thread. Okay, now here threading module means what? The modules which we are using means like we call it as a we call it as a thread life cycle. Okay, so here first we need to same import that thread. Here I will take the one function that will be the trace function. Means what? I want to trace something, so here track function is there, and after that profile means what? Somewhat we call it as a we are finding the profile of some of the student, or we call it as a faculty. Okay, to get the track of the work like that. So here I will first use the track function. Okay, so here track function is just simply I will print one of the message. After that I will define profile function. Okay, means what? The profile, in that profile I am just taking the one of the method which we are using in thread, that will be a current thread. Means what? Suppose in single program we are having more than one thread, so but we want the current thread. Means what? If suppose my program is in this stage, so that will be only a it will be return me the output for this first thread only. So we call it as a this current thread will be the that. And get name means what? It will be the give the it will be get name means what? The data which is present from that at the time of that current thread, it will be a return that data. After that here I am creating same class like a thread. All the creation of class in each and every program of thread, it will be a same. Like we are first we need to define that class. After that we need to define one of the function, that will be the init function. After that we are calling that init function in the our that method. After that we are taking the running method. In this running method we are writing the each and every point in the a descriptive manner, like you have to say here print number of active threads is equal to, we are taking the active count. Means what? The thread means currently in my program, suppose 3 threads are there, so the count will be the 3. If 2, then it will be give me the 2 count. And current thread means that process at last which thread will be executed. Okay, like that. Means what? We call it as a program which we are writing over there, that will be the thread base, but the all the overall execution we call it as a, that will be the process base. Okay, after that what we are doing, we are just taking the here I am executing 3 different threads. For thread 1 I will take the for fairy, then diploma and pharmacy, like that. After that what we are doing, we are taking just name of my main thread is, means what? Here we are taking the active count and the current execution of thread. So for that I am taking the my main thread name is what? Here our main thread name is what? The what? A thread, because our class name is what? Thread. Then after that the identity of main is some identity. It will be generated through the way which we are seeing over here. That will be the assigned through by this stack pointer of the this register set. Okay, after that we are initializing the stack sizes. Some size is assigned for this uh, execution of this process, so that will be displayed over here. And after that just we are starting all the threads. Okay, now suppose I will execute this program, so you have to say here my main thread is what? Thread, just my main thread. Okay, okay, so if suppose here my name of my main thread is what? Main thread. It will be written name a main thread. After that identity of the main is, the identity is like this. You have to see here, it will be written by the output is written by us the a CPU or the process which we are executing. Means suppose I will execute the same program many more times, so this number you have to see carefully. This number will be a changes for the each and every execution. After that the size is 0. Why? Because right now uh, we are just not putting any value to somewhere. After that set the profile of a thread main is none or 1. Means what? The profile which we are here is total 3 profiles are there here. A total 2 activities which we are performing in our this thread, that will be the string, related to string. Then the number of active threads, here it will be give me the 11, but you have to here in my program 3 are there, but in this program I will do the changes many of the time, so it will be written me the active thread is 11. After that number of current threads, it will be written me the 20. Why? Because this program I will execute many more times. Then you have to see here the identifying of main is here, the number which is represent over here and the number is represent here, it will be a different for each and every thread. You have to see here, if my program is executed at the same time, that will be the output will this number will be the same, that will be the id number is same. But if my program is executed in the a different type, that's like that it will be the change the program. So you have to see here this program right now currently I will execute 2 times. So here my main active thread is 11, but after the execution of my current finding the current state, it will be changed like active the number of active thread is 12. Like that. Means what? Each and every iteration the value of the number of activation thread will be changes. You have to see here now the representation. So the value it is not constant, it will be depend on your compiler. It will be a changes their value of the threads which we are executing many more times. So you have to say now here all the activation thread value will be 11. Means what? It will be a totally depend on the our system. The value of the thread will be the integers. Means the same program how much time we are executing, it will be a totally depend on that. The value will be a changes simultaneous. Okay, so this will be the a simple example of a thread. So and one more concept is there in this modeling, that will be the pull model. Okay, so pull model is what we are using this a pull model uh, for parallel execution of a function for different input data. Means what? Suppose any of the my suppose program will be having the different parallel execution. Means what? The output, the input which we are providing for my uh, program is different. Okay, so that time what we call it as a, we are using this full class model to execute that the function which is having different data inputs. Okay, so here we call it as a, we are using the multi-processing dot full model. You have to see here multi-processing dot full model which we are using. Okay, uh, then we uh, then we are using one of the apply synchronous and map function. We are using apply synchronous and map function here. So if we are using this model like this, so most of the time actually this pull model is used by in industry. Why? Because the execution is very difficult for pull model. We need some of the like background connectivity for this pull. Okay, so just simply here I will take the one of the simple example also, but it will be give me us the error. Why? Because it will be having some of the it will be not give us the proper output. So that time also it will be give us the some of the error. So we call it as a, this will be full model. Means what? You have to see in the this program what here I am doing. Here I am taking two different variable declaration. One is a input and other is a input.
स्क्रीन प्रेजेंट नहीं है.
Screen is not visible.
नो मैम.
No.
Just 1 minute. Okay, now my screen is visible.
यस मैम.
Yes, ma'am.
Okay, so I will explain once again. So pull model is actually, it will be the content beyond the syllables, that pull model. Okay, so pull model means what? It will be the use the a parallel execution of the function of different input data. Okay, different input data. So for that we are using multiprocessing dot pull method to work with this task of the different input data set. So you have to see here in my program, roll number 13, mute yourself. Okay, so here first we need to import multiprocessing. You have to make sure that don't confuse with these two concepts, that will be a threading and this multiprocessing. Okay, actually the in older concept we are means older syllabus concept we are using this multi-processing, but now today we are using the threading model. So multi-processing is used for the pulling for using the pulling class concept. So here other is a time. Here I will take the import the time model. After that here I just take the simple example of square root, and just here I will return the a formula for this. Means we call it as a, this will be the my main logic or my instruction which we are save in my register set. Okay, after that if name is equal to main, means what? It will be directly dealing with this, will be the syntax is, it will be directly dealing with this a multi-process. Okay, after that what we are doing, pull is equal to multi-processing dot pull, and after that multi-processing dot pull of process equal to 5. Okay, 5 means what? I will just give you the uh, give you the sum of the range, like these many processes are there, but we don't know how many processes are there and the same time. So okay, so that time we call it as a here I will give the process equal to 5. After that, what I am doing here, I am just passing one of the variable declaration in this variable declaration by using the list by using the list representation. I am declaring some of the value, the value which I declare over here. I want to find the square root of this number. So after that, I am taking one more variable declaration, that will be output equal to pull dot map. So map means what? We are using this map, or we call it as a synchronize. One more method is there, that will be the synchronization. So we are using this method to map that multiprocessing dot pull object to the my argument. Which argument? That will be this argument. Means what? We are using this line to uh, give the map or map with this. Why? Because if I will write first method, and after that I will pass this uh, values which I want to find the output. So by using this map, I will be connect this both, that will be input and this pull. And after that, here we are taking output equal to pull dot map of square. Why? We are calling this function here because we want to find the square. And after that, input data means what? This input data. And now here just simply represent what I should represent, a print input dot format of input and print output of that result. Means what? After execution of this, you have to see here the output, or we call it as a square root of the function. So this will be the other way. Means what? We call it as a, by using multiprocessing full class, we are finding the square root of the numbers which we are passing here. Okay, so this will be the one more concept which we are using over there. Okay, everyone understand? Yes, any doubt?
No, ma'am.
Okay, can I move further?
Yes, ma'am.
Okay, so next okay, next we will see one more small points. Okay, so next will be the context of variable. Okay, so we know that how to declare any of the variables. So one more concept is there, that will be the context variable. Okay, so context variable object in Python is an context variable objects in Python is an interesting type of variable which returns the value of variable according to the context. Means what? Context means what? The value which we are passing over there, it will be the return that value as compared to their program, or the value which we are entering in that program, like that. Means what? Context variable, we know that we are declaring a different variable. Okay, we are declaring different variables in different ways. So if we are using this declaration as a context variable declaration, so according to this, each and every time it will be a return as the sum of the different outputs. So it many having multiple value according to the context in the single thread or execution. Means what? We know that we are having at the same times we are executing more than one thread in our program. So it depend on the execution of the threads, the what will be the value, it will be a return. The context variable class represent in the context variable module, which is used to declare the context variable in Python. So you have to see here the syntax. Context variables dot context variable of name and default value. Means what? Which we are writing in our program. After that, we are having some of the methods which we are using to access that context variable, that will be the get, then set value and reset. Now, the get value means what? You have to consider that get, if we are writing that get method means what? We want to get some data from the from this. This what, like a we call it as a we are writing the scanf or we are writing the printf statement. So get means what, we are collecting some data from them, so we call it as that will be the get method. Set method means what, we want to most of the time we are not using this set method. Why? If we are using set method, it will be means what, the value which we are entering over there, it will be the fixed value, it will be a not changeable value, so we call it as a, that will be the set value method. And after that reset means what, we are resetting some of the value which we are setting over there. So it will be a reset means what, it will be the combination of this both set as well as a reset. Then after that we are having token class in this context variable. So token class means what, we are having same three more functions or properties, we call it as a properties. Like a token dot variable means what, it will be a return as the output as a set value, means what, we are our output will be the fixed that value which we are putting in this set method. After that the token old value means what, we are using reset function, means what, suppose my first value is 1, but after performing this reset operation my value will be 2. So the output of this old value will be the 1, and the token missing, use the null by token old value, means what, suppose I will after 2 to 3 execution, what I should do, I will erase that data, the value which we are setting over there, that bracket I will be put it as empty, so it will be return me as a missing, means token is missing, means we are not putting any of the value over there, so it will be returned the output like that. So we will see one by one here all the methods, so it will be understand. So first we need to import the context variable package. We need to import the context variable package which we are declare over here. Then after that I will take the one of the variable declaration, c variable equal to context variable dot context var, which is this is a standard syntax which we are seeing over there. Then name and default value. Name means what, my name of my variable is what, c variable which I will give the name for my program. After that default is equal to variable, means what, it will be the default, means by default the my name will be their variable. Okay, we are finding the variable, so I will give the name it uh, name to it, that will be the variable. After that what I should do, I will simply print one of the statement, value of context variable slash n is equal to c var dot get. Get method means what, I want to get some of the value from that get method, so call the set method here. Why? Because I am not setting I want the value, means why, by using this get function I want the some of the value, but here I am not putting any of the value in this get method. So what I should do, I will call the set method first. In set method, what I should write, I will take one of the variable that will be a token is equal to c var dot set change. Is what message I will put here, that will be a change something like that. So I will put message in set that will be changed. After that I will call the get method once again in my printf statement, and after that same check the token instead of this type, means the find the type of this variable which we are writing. And I will once again, now I will suppose execute this program. So you have to say here first the name of my default is what, the variable, but after doing the set operation it will be the change, and after that the token of my class will be the resetting will be the variable, means what, it once I will set, after that I will take use the method set token, means what, it will be get give me the old value, the what is my old value, that will be the variable, and in between change I will change the value, that will be this value. So this will be the output for my a simple two method, that will be get method and set method, means what, just simply we are setting any of the value by using set method, and we are calling this get method in my printf to get that value, the value which we are entering to set that function. Okay, here next will be for the property which we are using for the context variable. Okay, so simply here first I will declare one of the context variable, in that name of that concept and default value. After that I want to change that value. For that I am using set function. Now here I will write context of print of, I want to here generate a token for this context variable, which for this context variable I want to generate the token. For that I will take token dot variable, which we are seeing here. Here for means what, it will be give us the to create the token and return the context a set value. So this will be return me the a token which is generated by the a set method. After that it will be give me the like a token of old variable. Old means what, the value, old value which we are setting for my context. Like suppose my first value will be 1. After using setting operation I will change my value to 2, but now I want to find the previous value, so we call it as a, that time we are using this old value uh, method in context variable. And then I will change once again after finding old value I will change once again my new I will change once again the value for my that context variable, and same the operation I will perform twicely. So you have to see here, first it will be give me generate the token. It will be this value is called as our token value. It will be a changes for each and every iteration. Okay, after that calling the token old value. So here it will be written me as a token missing. Why? Because here I am not giving the access to this variable to access over there, so it will be give me result that a token is missing. After that here I will call the set method. The source at set method my value will be a change, but after this change I want to find my old value, so it will be the old value. Now it will be give me the sorry, here after I want to find here old value, but it will be accessed through this what just change. But after that it will be give me the change to value. Why? Because here I will perform the set operation 2 times, once in this token, and after that execution after the execution of this line, that is finding the old value. So I know that my old value will be a change, but performing the this this old value operation means it will be written with the change to. So this will be the simple context variable operation. Actually this point also we are not using many of the type, because better for this variable declaration is very some of the difficult or confusing. Apart from this we are using the simple variable declaration, that all the methods are better than this. Okay, so this will be the one of the part that we are learning, that will be the context variable. So one more point, that will be asynchronous input output. Means what, this operation means what, we are using different, we are using different input and output functions in our program. Okay, we are using different input and output function in our program, so we call it as a, that will be the asynchronous method. Means what, so in some of the program we are writing, in some of the program we are taking the input from user, and some of the time we are putting directly input value in our program, so we call it as a, that will be the asynchronous method of taking the input and output in our program. Okay, so this part we will cover today. Next part, that will be the introduction to GUI programming, we will see in the next lecture. Okay, up to this point, any doubt, like a thread, process based parallelism, thread based parallelism? Yes, any doubt? Yes, any doubt is there? Yes, roll number 1.
Present, ma'am.
Any doubt?
No, ma'am.
Okay, so now today we will stop here, and next lecture we will see the last point is remaining, that will be the introduction to GUI programming, Python. Okay, so now you all may leave the meeting.